z is equal to a plus bi. The complex conjugate of z bar, is equal to a minus bi. When we have this bar, that means we have a complex conjugate of root 3 plus I, and that is root 3 minus I. That's the complex conjugate of root 3 plus I. Now, let's substitute this into that. Then we say this will give us 3 minus I plus root 3 minus I to the power of 3. Now we have 3 minus I plus root 3 minus I multiplied by root 3 minus I squared. That gives us 3 minus I plus root 3 minus I, and if you expand that, you get 3 minus 2 root 3 I plus I squared. But you know, I squared is equal to minus 1. So we shall substitute I squared with minus 1. So we have 3 minus I plus root 3 minus I into 3 minus 2 root 3 I minus 1. And that gives us 3 minus I plus root 3 minus I. 3 minus 1, we get 2. So we have 2 minus 2 root 3I. Now let's expand what we have. We have 3 minus I plus root 3 times 2, we get 2 root 3. Root 3 times minus 2 root 3I, we get 6I. So we say that is minus 6I. Minus I times 2, you get minus 2I. Minus I times this, you get plus 2 root 3I squared. And we have 3 minus I plus, you remember, I squared is equal to minus 1. So we say 2 root 3, we can add these. We have minus 8I. Minus, you remember, we're putting a minus 1 on I squared, minus 2 root 3. Now let's simplify what is in the parentheses. We have 2 root 3 minus 2 root 3. We get 0. So we have minus 8I. And then we say 3 minus I minus 8I. And that gives us 3 minus 9I. And we have managed to simplify that complex number.